In the star system Orion, there is a star that has charmed cosmologists for an extended period. This red, incredibly gigantic star is much more prominent and larger than our Sun. In recent years, Betelgeuse has been acting particularly oddly. It has decreased considerably in brightness and has even begun to vibrate violently. This has prompted theories that this once extravagant star is moving toward a catastrophic impact. Yet, consider the possibility that we may be witnessing the beginning of a more complex and unsettling event. There is a chance that Betelgeuse won't explode but will instead collapse in on itself. Join us as we explore the latest research on Betelgeuse and its potential ramifications for our planet. Through this investigation, we aim to understand the significant impact Betelgeuse's breakdown could have on the future of the universe. The privileged secrets of Betelgeuse, a monstrous star, are often many times greater than our Sun and rank among the universe's largest. However, its size comes with a cost. Stars like this have limited life expectancies, and Betelgeuse is no exception. It's a ticking time bomb, ready to detonate, but the exact moment remains a mystery. Situated about 650 light-years away, Betelgeuse has astonished cosmologists, shining as one of our nearest stars. We marvel at its splendor, trying to unravel the secrets hidden within its searing depths. However, only 13.3% of its brilliant energy is apparent to us. If we could see its full glory, it would outshine even Sirius in the night sky. Imagine a titanic star with a range comparable to our Sun, extending beyond the asteroid belt and nearly touching Jupiter. Within this immense region, Earth, Mars, Mercury, and Venus would be engulfed by Betelgeuse's massive gravitational pull. However, the surprises don't end there. Every few hundred years, Betelgeuse sheds a solar mass, pushing off its outer layers in a brilliant display of colossal beauty. A cloud larger than the actual star envelopes Betelgeuse, covering it in an ethereal mist that captivates our gaze. This cloud, extending 30 light-years, invites us into a grandiose dance, beckoning us to uncover its secrets. To understand Betelgeuse's creation, we must delve deeper into its core, where the nuclear fusion of hydrogen creates helium in a massive reaction over time. The star's hydrogen fuel decreases, leading to significant changes as helium merges with carbon, creating brightness that travels through the universe. However, even this brilliant fusion has its limits. As neon combines with iron, a significant change occurs. The star's gravity, weakened by the depletion of energy, triggers an impending collapse, pushing Betelgeuse toward a fate that is both stunning and tragic. The fate of Betelgeuse undergoes a mesmerizing transformation, progressing from the energetic blues of youth to the blasting reds of development. During the 2nd century BC, Chinese stargazers observed an exceptional visible phenomenon. Betelgeuse's distinctive yellow hue set it apart from the celestial embroidery. As the centuries unfolded, the mantle of perception passed to Greek and Roman cosmologists. For example, in the 2nd century AD, Timaeus noted Betelgeuse as having an orangish or tanned appearance, a characteristic that continues to enthrall us today. This diligent tone, noted across various cultures, adds to the intrigue surrounding Betelgeuse. The tale of Betelgeuse takes a new twist as we delve further into its erratic behavior. In 2019, the star shocked investigators by unexpectedly dimming. Scientists initially believed that a massive dust storm released from the star's surface had clouded our view, yet the origin of the cloud remains unclear. Some researchers speculate that a massive object, like a planet, might have disrupted the star's surface or even been consumed by it. Recently, Betelgeuse has become twice as bright as its normal brilliance. This is astonishing since stars typically dim as they age. Analysts are uncertain about the cause of this abrupt increase in brightness, but they know that stellar luminosity can vary due to various factors. Some stars undergo cycles of bright and dim stages, and Betelgeuse is classified as a variable star, as it consistently changes in brightness, expanding and contracting regularly. This alteration affects how much light it produces, a common occurrence with many stars, including Aldebaran and around 30 other stars visible in the night sky without a telescope. An immense explosion within Betelgeuse's core has been occurring, with the expulsion of stellar material into space creating a vast dust cloud. This dust cover has obscured a significant portion of Betelgeuse's brilliant light, transforming it from a dazzling beacon to a diminished star in the night sky. Betelgeuse's brightness has dropped to previously inconceivable levels. Once considered among the top 10 brightest stars, it now ranks lower than the 20th. In the months that followed, Betelgeuse's behavior has continued to astonish space experts, challenging established theories. Theories abound, attempting to unravel the mystery of Betelgeuse's erratic behavior. Some suspect that enormous sunspots or dust clouds are responsible for its dramatic fluctuations, while others analyze the probability of repeating patterns. Their research has unveiled a disturbing possibility. Betelgeuse's stellar explosion might have already occurred. Yes, you heard that right. While past estimates projected its massive explosion to be centuries away, current evidence suggests an alternate story. The implications of a supernova blast could be profound. The last notable grand explosion in our system, the Kepler astronomical blast, graced the sky many years ago. Specialists have proposed a model suggesting that Betelgeuse is in the late phases of carbon burning, indicating it could be approaching a critical explosion. This positions it as a strong contender for the next expected astronomical blast in our Milky Way, like a grand finale in a divine symphony. Betelgeuse remains a notable candidate for the next celestial explosion in our valued Milky Way system. However, focusing on Betelgeuse resembles tackling a riddle with conflicting perceptions. There are signs of material releases and resulting recovery, leaning toward a mass ejection event, but on a smaller scale compared to our Sun. Observational challenges and the visibility of stellar explosions complicate matters. The trouble lies in our current inability to observe Betelgeuse with precision. Researchers have been studying Betelgeuse for a long time and have found that its brightness has fluctuated over time. This suggests that the star is aging and could go supernova soon. However, there isn't enough evidence to predict precisely when this will happen. A massive explosion is an incredibly brilliant event that occurs when a star dies. It is not destructive to life on Earth and is safe to observe from our planet with the naked eye. Understanding Betelgeuse's role in astronomical evolution, Betelgeuse, a red supergiant in the Orion constellation, plays a critical part in the life cycle of stars within our galaxy. Its evolution offers a window into the fate of other massive stars, providing critical insights into the end phases of stellar life and the effect of supernovae on galactic environments. To comprehend Betelgeuse's significance, we need to delve deeper into its stellar architecture, life cycle, and the broader implications of its potential explosion. Heavenly development and supermassive stars. Betelgeuse, classified as a red supergiant, is the result of the later phases of stellar evolution. Unlike smaller stars, which burn their hydrogen fuel more slowly and enter a red giant stage, massive stars like Betelgeuse consume their nuclear fuel at an accelerated rate. This rapid consumption leads to the expansion of the star's outer layers and the formation of a supergiant. The core of Betelgeuse fundamentally comprises helium and heavier elements like carbon and oxygen. As the hydrogen in the core is exhausted, fusion reactions begin to occur in the outer layers, prompting the star's expansion. This process is governed by the complex interplay of gravitational forces and radiation pressure, which eventually results in the star reaching its supergiant stage. The core fusion process at the center of Betelgeuse continues to drive its brightness and size. Initially, hydrogen fuses into helium in a series of reactions that release tremendous amounts of energy. As hydrogen is exhausted, the core contracts under gravity, increasing temperature and pressure. This allows helium to fuse into heavier elements like carbon and oxygen. The star's outer layers grow significantly during this stage, resulting in its enormous size and characteristic red color. In supergiants like Betelgeuse, this process is more complicated due to the star's high mass. The core goes through several fusion stages, creating a series of concentric shells where different elements are fused. Each stage of fusion alters the core's composition and energy yield, affecting the star's dynamic behavior and potential instability. The supernova mechanism. When Betelgeuse exhausts its nuclear fuel, it will no longer have the energy to balance the gravitational pull of its own mass. This leads to a dramatic collapse of the core, triggering a supernova explosion. The supernova mechanism involves a sequence of rapid events. 1. Core collapse. Without sufficient pressure from fusion reactions, the core succumbs to its own gravity. This collapse occurs at a staggering rate, compressing the core into a neutron star or possibly a black hole, depending on its mass. 2. Shock wave development. The collapse creates a massive shock wave that travels outward through the star's outer layers. This shock wave heats the surrounding material, causing it to explode in a brilliant eruption of light and energy. 3. Ejection of outer layers. The outer layers of the star are expelled into space, enriching the surrounding interstellar medium with heavy elements. This ejected material contributes to the formation of new stars and planetary systems, continuing the cycle of stellar evolution. Betelgeuse's influence on its galactic neighborhood. The explosion of a supergiant like Betelgeuse has significant ramifications for its environment. The ejected materials from a supernova can influence the formation of new stars and planetary systems. The shock waves from the explosion can trigger the collapse of nearby molecular clouds, leading to the birth of new stars. Additionally, the heavy elements produced in Betelgeuse's core and expelled during the supernova contribute to the chemical enrichment of the universe. These elements are essential for the formation of planets and the emergence of life. Consequently, Betelgeuse's life cycle plays a crucial role in shaping the chemical structure and architecture of our galaxy. Notable observations and cultural significance. Since ancient times, Betelgeuse has been a prominent feature in the night sky, influencing various cultures and astronomical studies. Early civilizations often noted and recorded the behavior of celestial bodies, including Betelgeuse, which was recognized for its distinct color and brightness. In archaic Europe, Betelgeuse was associated with various myths and divine beliefs. Its reddish tint and prominence in the constellation made it a significant landmark in the night sky. Its visibility and changing brightness were often interpreted as omens or signs in different cultures. Modern astronomy and Betelgeuse's behavior. Betelgeuse has become a focal point for astronomers due to its unusual behavior and the potential for a supernova event. Advances in observational technology, including space-based telescopes and high-resolution imaging techniques, have allowed scientists to study Betelgeuse in exceptional detail. Researchers use various methods to monitor Betelgeuse's behavior, including photometry to measure changes in brightness and spectroscopy to analyze the star's composition. These observations help researchers understand the star's current state and predict its future evolution. Challenges in predicting supernova events. Predicting the exact timing of a supernova is a complex and challenging task. While researchers can estimate the likelihood of a supernova based on a star's age and behavior, precise predictions are difficult due to the many variables involved. Factors such as the star's mass, composition, and overall environment can influence the timing and nature of the explosion. Current models of stellar evolution and supernova mechanics provide valuable insights, but much still needs to be understood about the specific conditions that lead to a supernova. Continued observations of Betelgeuse and other massive stars are crucial for refining these models and enhancing our understanding of these cosmic events. Betelgeuse's role in stellar evolution. The study of Betelgeuse provides significant insights into stellar evolution. By examining the star's behavior and characteristics, researchers can gain a deeper understanding of the life cycles of other massive stars and the processes leading up to supernovae. Betelgeuse's unique properties, such as its size, brightness, and erratic behavior, offer valuable data for developing and testing theoretical models of stellar evolution. Additionally, studying Betelgeuse's behavior helps astronomers understand the broader context of star formation and galactic evolution. The star's interactions with its environment and its impending supernova will contribute to the ongoing cycles of stellar evolution, influencing the formation of new stars and planetary systems. Public interest and educational outreach. The dramatic nature of Betelgeuse's behavior has captured the public's imagination and sparked widespread interest in astronomy. Educational outreach programs and popular science articles often feature Betelgeuse as an example of the captivating and dynamic processes occurring in the universe. Public engagement with such topics fosters interest in science and promotes a broader understanding of cosmic phenomena. Future observations and research directions. As technology continues to advance, future observations of Betelgeuse will provide even more detailed insights into its behavior and evolution. New telescopes and observational techniques will enable researchers to monitor the star's activity with greater precision, revealing additional clues about its impending supernova. Scientists are also exploring the use of computational models and simulations to better understand the processes occurring within Betelgeuse and other massive stars. These models help predict the star's future behavior and refine our understanding of the mechanisms driving supernovae.